range sum query interview question. What is the range sum query interview question? In this question, you are given an integer array called nums. So you have nums, which is an int array. The question is, given I and j, where I is less than or equal than j, give the sum of all the items between I and j inclusive. Okay, so let's think how you would think about this question in an interview. So there are things you must do, and I'm not sure that you will do them, but you really must do them. But in an actual interview, I'm pretty sure you might forget or think that it's unnecessary, but please, it's very necessary. The first thing is draw the example, and try to manually solve it. The second is think of patterns to solve it. For example, I will introduce you into a pattern that its name I really invented, it doesn't matter. I call it the diff pattern. There is another thing that I didn't tell you about this question, and it is that the question also says that there is a constraint. So the constraint is that there will be many calls to the function. So if the function is called some range, many calls, there are going to be many calls. So let's first try to see how we would do it without drawing any example, and then we would draw an example and see how it helps us. So first, without doing an example, so I have an int array called nums, and I want the sum range of I to j. So if this is the array and this is I and this is j, I want this sum, and this call to sum would be called many times, which means it's important that it would be fast. So of course the first thing I could do is with a simple for loop from I to j, I could just sum, right? Nums index, current index. The problem with that is that each time this function would be called, I would do like O of n, the complexity, the time complexity of this function is O of n, because each time this function would be called, I would traverse the items. But we could do it this way, and it's possible that this would be our first brute force solution. I advise you to stop now and think, could you do it faster? Okay, I'll be back in a few seconds. The first thing we could do is at the constructor of this function. So if we have like a constructor public which accept the original array, then here we could compute all the subsums. Right? We could compute them all, but each such computation would cost us O of n, And how many subsums are we going to have? It's not all the subgroups. It's first the subgroup 1, then 1 and 2, then 1 and 2 and 3, and we also have 2 and 3, right, and 3 and 4, and 1 and 2 and 3 and 4. All these guys. What is the space complexity? If you think with it, then for the number 1, we could have 1 and 1 and 2 and 1 and 2 and 3 and 1, 2, 3, 4. So we have, only for this number 1, we have n items. And for the number 2, we could have 2, and of course this one, but we already counted it with 1, 2 and 3, 2 and 3, 4. So for this one, we also have n. So for each number, we have at most n items. So it's at most n squared items. So it looks like we got a little bit better, but we have a lot of space and also a lot of calculations, because only for one item we need to do of n calculation of the sums for only one of the sums. So we have too many calculations because we need to compute all the subsums. The thing I wanted to show you here is that we try to solve the problem without drawing an actual example. So let's see how it's going when we do draw an example. When I draw an example, it's going to look like this: 2, 4, 1, 0, 4. So when we want to calculate the subsum, it's going to be like calculate this thing. So they will ask us to calculate this thing between j and I. So notice something here, and if they want us to calculate this one, so this would be j and I. So if you look at it, then if they want us to calculate this sum, it's going to be only this. So notice something interesting. Do you see something from this picture? Because if we want to calculate this sum, it's going to be the sum of all numbers minus this sum, right? Because the sum of all numbers is the sum of this section plus the sum of this section. Okay, let's draw another example. If we want to calculate this sum, it's going to be the whole sum minus this sum. So once we have drawn an example, we suddenly see another way. And this basically means that when we got the actual numbers, we could simply try calculating each of the sums maybe in a smarter way. And what would be the smarter way? The smarter way is actually when we look at this and we said that if we want to calculate this subsum, then it's the whole minus this one. So let's say we get in the constructor the array. So public num array okay, so the first sum of the first I is simply the first item. So let's do that. So we start it's simply the first item, so we don't need to calculate it even. So let's start with the second item. So we define that the second item so our loop is going to actually start from the second item. Notice here I equals 1 and not 0 because we're starting with the second item, because the first item is already the sum of itself. Okay, so each item starting from the second one, we said in the definition what's its sum. Its sum is the next item plus the sum of the previous item, all the way down. So we calculate first, if you look at it like this, we calculate first this sum, and then this one, 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 and then if we need this section, we know it's the whole of this minus this, and if we need only let's say this section, then it's simply this sum, this, which is the whole sum, minus this one, simply the diff. So this is the diff pattern. The diff pattern says that when you deal with arrays, you should check whether your operation could be a diff, because you see we can incrementally calculate the sums, and then each subsum is a diff. It's a diff between this and this, or diff between this and this, or this and this, which gives us this subsum. So it's very easy to calculate it. So our loop for calculating all the sums, but all the sums are starting from 0, is that we first do, as we said, I starts from item 1, right, and then each item, and this is another pattern, we could override the actual items, so we use the same space complexity. So if our argument was named nums, we use the same argument. This is another pattern, override the input array to save store. Nums I is actually the sum of the current item, which is why we put here plus equals, plus the previous sum. Notice that here the nums are not the nums anymore, we are converted them to be sums, right? And then when we need to calculate the sum range, we simply do this. Range. So function now would simply say that if I is 0, we simply return so if we need to calculate the sum from 0, we simply return the sum up to j, which is nums j. That's it. It's the sum up to j. Remember, we had I and j, but if I is here, we already have the sum. We calculated it and placed it here. If not, we do the subtraction. So we return, if not, then we return the sum up to j minus the sum of I minus 1, because this is I and we want I to j, so it's the sum of j minus the sum of I minus 1. So return nums j, and remember nums is not nums anymore, we made it sum, minus nums I minus 1. Okay, so what do I want you to learn from all this? I want you to learn two things. One, diff pattern, which means that for arrays, sometimes you can calculate stuff by simply doing a diff in the array. And this will save you a whole lot of trouble. So when you get a question about array, maybe diff would help. Second item is that you could change your input argument. Arg reuse. And with this you save a lot of space. And that's it. So the diff pattern says that when you need to do some accumulative operations like sum of ranges, then remember that the sum of ranges could be produced by the sums, and you can then do subtraction of sums to get a sum of a specific range. And this was the solution to the range sum query. Thank you for watching, and I will see you next time.